Hi everyone, my name is Chen Yin Ru from the School of Physics, majoring in pure physics. In the video, I'm a script writer.
Hi everyone, I'm Saik Ziyang, first year student from the School of Physics majoring in pure physics. In this video, I will be your presenter. Do you know what a penning trap is? Penning trap is a device that used to store charged particles using magnetic field and electric field. It is mostly used in physical science or related field of study as a tool for precision measurement of properties of ions and stable subatomic particles. For instance, mass, fission field, and isometric yield ratio. These traps are also used to realize quantum computation and quantum information processing by trapping qubits. Penning traps are in use in many laboratories worldwide, including CERN, to store and investigate antiparticles such as antiproton. The penning trap has proved to be a useful tool in mass spectrometry and has been used to make the most accurate measurement of the mass of a number of stable nuclei. However, in order to reduce the statistical uncertainty in the measurement of a mass in such a trap, it is necessary to store the ion for relatively long times, from minutes to hours. The Titan project aims to measure the masses of short-lived radioactive nuclei, where their half-life is around 50 milliseconds, and so it is clear that it is not possible to store such ions for a long period of time. It is, however, possible to obtain the required reduction in statistical uncertainty by injecting highly charged ions into the trap. In order to trap a charged particle, we need a quadruple potential with a three-dimensional minimum, with all the coefficients A, B, and C is positive. However, Laplace equation requires that the sum of all the coefficients A, B, and C is 0. Therefore, three-dimensional trapping is not possible with static field. There are two ways to trap a charged particle: by using oscillating field, which is how Paul traps work, or add a magnetic field, which is how penning trap work.
Two hours later.
Penning trap use a strong homogeneous axial magnetic field to confine particles radially and quadruple electric field to confine the particles axially. The static electrode potential is generated using a set of three electrodes, a ring and two end caps. The ring and end caps are hyperboloid of revolution. To trap a positive ion, the end cap electrodes are kept positive relative to the ring and vice versa. The potential will produce a saddle point in the center of the traps, which will trap the ion along the axial direction. At the same time, the radial motion of the particle is very unstable. Thus, a strong magnetic field, or in short B field, is applied along the axial axis of the trap to provide radial confinement and force the ion move in cyclotron loops. The ion will also undergo a second smaller or reduced cyclotron motion because of the applied electrostatic field. So the resultant motion will look like this. The use of penning traps have different advantages. First, it provided an isolated and stable environment. The particles do not interact with the container walls or residual gas. This means exotic particles like antiparticles and highly charged ion can be trapped. Its second advantages are tight localization of the particles. Due to the electrical potential and magnetic field, particles remain in the center of the trap and cannot escape. This makes long interaction times, especially after laser cooling, is possible. The third advantages are the magnetic field used by penning trap is very uniform and stable. Thus, it is also useful for mass and G factor measurement. The fourth advantages are different cooling technique available. This will increase lifetime of trapped particles and reduce or eliminate Doppler effect. At the same time, penning traps also have some disadvantages. Access of penning traps to the ion is very difficult because superconducting magnet limits access severely. The electrode of the trap makes optical access to the ions become difficult too. Poking any holes on the electrode is not a good idea to solve this problem, as any holes in the electrode would distort the quadratic potential. Besides, for the trap to function as it should be, vacuum system needs to be very good for ultra high vacuum, where less than 10 to the power of -9 millibar. Another disadvantage is the magnetron motion is unstable. It leads to a rotation of the whole plasma.